Hi everyone, welcome to my talk about Flutter app-to-app. First few words about me. My name is Marcin Chudy. I'm a senior Flutter developer at Lean Code. We're a software studio based in Warsaw, Poland. We're specializing in Flutter apps. We're also active in the Flutter community. And for 2 years I have been serving as a role of Flutter tech lead and one of the major Polish banks, actually a Polish branch of a Portuguese bank. I started mobile dev actually with React Native and then switched to Flutter. I've been doing Flutter for over 4 years now. You can find me on X. And we all, as developers, we like developing new greenfield projects. We like starting everything from scratch, doing things the right way this time, learning from old experiences. But the reality is that there are many companies that have huge native apps with a lot of debt, and although they would like to start with Flutter, it's not always that simple. So this is where Flutter app-to-app comes in. So Flutter app-to-app is a way to add Flutter to existing native applications. Flutter app-to-app is can be both used for rendering part of the UI in Flutter inside a native app. It can be also used only for running Dart, shared Dart logic. It's actually been in Flutter for a very long time. It first landed as stable in Flutter 1.12, which is at the end of 2019. So it's been with us for a very long time. And why we might want to use app-to-app? So what are the main use cases for it? The first, the most obvious one, is that we just cannot afford a full rewrite of our native apps at some point. So Flutter app-to-app can serve as a way to slowly migrate our app to Flutter to leverage the cross-platform possibilities of Flutter. So we would start with rewriting some small one feature or one module in our app, or writing a new feature in Flutter. And then over time, we can slowly start rewriting existing features to Flutter. And maybe at the end, we'll be able to make a switch to a fully Flutter app, possibly with some native modules for some of the stuff very likely to happen in huge native apps. The other use case, which might not be that obvious, is that app-to-app is an interesting use case for testing the technology and proving to stakeholders that Flutter is capable of doing the job. And this was actually our use case. The nice thing you can do with app-to-app, you can rewrite some couple of screens in Flutter. You can build an app with Flutter, build an app as fully native, and you can even give 2 phones to some stakeholder and see if they can tell a difference between those 2 apps. And that's a very effective way of convincing people that Flutter is a good technology. And this is also what we did at some point in our project. Also, if you want to put this to production, you can run some A/B tests to run Flutter on Run Native. You can gather some interesting data from that. You can also do some user quality testing to gather some qualitative data. So that's a very interesting way of looking at it. Another more contrived use case, but showing that we can scale it, is that we might have some feature that can be used across multiple apps. Some of them can be native. Some of them maybe will always be native, but some part of it is really usable, and we can keep it as Flutter part. And that can also be used for some Flutter applications, so that can give us a nice cost effectiveness in the long term to maintain this piece as Flutter module. So now we have some use cases on why we might want to do add to app. Now let's take a look how we actually do it. So we start with the documentation. When we first started our POC with add to app, the documentation was quite scarce. It has improved a bit over the time. For example, now it also mentions integrating with Swift UI, with Jetpack Compose, with newer technologies. But the thing to remember with add to app always is that it's not the default way of building Flutter apps. This is not how you would ideally build your Flutter app. Documentation and resources in the community are much harder to find than for standalone Flutter apps. So if you stumble upon some problems, they will be harder to solve, especially as they might involve some project-specific things. And the bottom line is, if your app is huge, it probably won't be that simple to just put Flutter there. And on the other hand, if your app is small, then probably the better way to do it is just to do a full rewrite straight away. So we are only considering this for huge native apps, really. And now let me take you through our use case. So our use case was, as I mentioned, a Portuguese branch of a Polish branch of a Portuguese bank. And the idea was that the app for corporate clients they had a native app. It was very old, not really maintained anymore. And they wanted to do it in Flutter, but they were not really convinced. And those were quite big apps. So the iOS had 500,000 lines of code. The Android was even bigger. And we were asked to do some POC to rewrite one complex business process in Flutter. As I will show you later, it was not just a simple screen to rewrite. It was a bit more than that. And the idea was that to prove with rewriting part of the existing app in Flutter is that Flutter is capable for a new project. And in the end, it has proved to be capable. We actually rewrote this app from scratch in Flutter, not longer using add to app. It's now in production. It's doing pretty well. So how do we go about this Flutter module? So the first thing to consider, one of the most crucial ones, is navigation. So let's take a look at some scenario, how we might want to integrate Flutter. So we have a bunch of native screens. We can go navigate between some native screens. And at some point from one of those native screens, we might want to run a Flutter screen. And this Flutter screen can then maybe navigate to some other Flutter screens. But what we can see here is that this is some kind of Flutter self-contained module. So once we enter Flutter, we are now in Flutter world. We can go back to native by just exiting this Flutter module. But that is a quite simple case. So more complex case can be seen here. So here we have some native screen, then we go to a Flutter screen, and then we can go either to a Flutter screen or a native screen, and then we can, from those Flutter screens at the top, we can go back to native, and from the native screen we can go to Flutter again. So basically we're kind of mixing native and Flutter views as we want. And this is generally, this complicates things a lot. So now we need to talk a bit about Flutter engines. So Flutter engine is a single execution environment for Flutter. If you're writing a pure Flutter app, you don't really see the Flutter engine, how it runs, how it gets initiated. But with add to app, this is basically how you run your Flutter module inside the native app. You have to take care of it yourself via the native code. So to run a Flutter view inside of your application, you need to start a Flutter engine. this Flutter engine actually starts the Dart entry point, as do you specify. But the thing about Flutter engine is that it holds the state of your screen, holds the current state of the UI, it holds all the state management that you're using. If you're using blocks, the blocks state are kept in memory, or river pod or provider, anything else. So the main implication of that is that if we have two Flutter paths in your navigation graph, like here, when you want to start path B, you cannot reuse, at least not in a straightforward manner, the one that's supported by default. You cannot reuse the existing engine because it holds the state of the previous screen. And if you try to do it, then when going back to path A, everything would break down because you would have the state of path B there. So in this scenario, you actually need two Flutter engines. So when you go to path B, you need to start a new engine. The thing about engines is that they should be pre-warmed. The initialization of an engine is a very expensive operation. If you ignore it, if you don't pre-warm it, it will be visible to the user. They will have a blank screen for a visible amount of time, so that's not good for user experience. The one optimization that Flutter team did is they introduced a Flutter engine group, I think something like 2 years ago. And Flutter engine group is a way to reuse resources for multiple Flutter engines. So like in this scenario, when you have two Flutter engines, when you start the second one, you don't really need to initialize everything from scratch. You can reuse existing resources. So you should really always use Flutter engine group for starting new engines. And one interesting scenario related to navigation, which is something that it's hard to predict when you start a new project, is that the native app that we are integrating with Flutter use this kind of iOS top bar animation when moving between screens. And when we had navigation from native to Flutter screen, that could be done because we could just keep the top bar native and go from native to Flutter and make the Flutter screen only the main part of the screen. But we had a couple of Flutter screens, so we had to navigate between native, then Flutter, and then Flutter. And actually, I'm sure there is some way to solve this, but the interesting outcome of that is that we actually rewrote some more screens to Flutter. We found it would be quicker rather than trying to find some workaround for that. So that also proves that writing UI is pretty quick, also in app to app. And that's actually my next point, is that writing UI in Flutter, we all love it. This is a principally UI framework. And with app to app, it's the same thing. So if you enjoy writing screens, widgets in Flutter, you will also enjoy it into the app-to-app scenario. The complexity lays in the integration with the native platform, but not in the UI itself. But the thing is that when you introduce Flutter to native apps, you have some design systems, that set of components in your iOS app, in your Android app, and now you will need to develop and maintain a third set of components in Flutter. So every change in the UI, in the design system, now has to land not in 2, but in 3 platforms until you are able to migrate. So you actually add some maintenance costs there. Also, there is iOS and Android components might be different, of course, so you need to pick one source of truth, most likely in Flutter, or support 2 versions, which is even more complex. So generally, here the maintenance is a bit increased until you actually are able to migrate fully to Flutter. How about assets? So you might think that we have a lot of assets already in our native app. we want to use the same assets like icons, images, illustrations in Flutter, can we actually do it without duplicating everything in the binary? And there is good news and there is bad news about this. So the good news is that we can do it on iOS. There is a package called iOS Platform Images, and it allows you to use native apps in your Flutter module. The bad thing is that there's no such thing on Android. There's an open issue. Maybe it will be solved at some point in the future. Currently, there are, as I'm aware, there are no plans to do that. It is technically possible. It just needs implementation. And the important point is that you don't have to rewrite everything, all parts of the UI, because something like this is also possible. So you can run native subviews inside of your Flutter screen. The other way around is also possible, so you can have native screen and small subviews which are written in Flutter. So this is interesting for some scenarios, like there are very complex native components that you don't want to rewrite to Flutter at the start because it's a lot of work. You want to focus on rewriting screens and other business features. A note on that is, of course, every of these Flutter subviews actually needs a separate engine because it's a different entry point. So you cannot use one engine to render different parts of the UI. It needs to be separate. Another thing, networking. So how do we deal with communicating with APIs? So first thing, we can do it two ways, basically. One is that you might think that we have the native API client. It's using native features. So why reinvent the wheel? In Flutter, maybe we can just use the native part that's already there. And it can be shared between native code and Flutter code. And the advantage is that you don't need to rewrite all the endpoint models that there might be generated anyway from some open API spec or something. The good thing is that the whole authentication logic, dealing with some headers, all of that is already implemented. Refreshing tokens, all of that is already implemented in the native app, and we don't need to care about it. Of course, we need to proxy everything, so there will be some performance overhead. Probably not a huge deal, but that should be checked. And we need to implement this bridge with method channels to actually call the native API client, which is always a maintenance cost. The other idea is that we use Dart HTTP client and build on top of that. So now we have no extra overhead for Flutter native communication. Probably the most important thing for developers is that Flutter devs have full control on how they consume the API, how they do networking. We need to duplicate the code that for all endpoints and models that we are calling. The trickiest part of all of that is synchronizing state. So you need to refresh the token, and there might be requests running from both Flutter and native if you go between screens, for example. So dealing with that can be a bit tricky. You need some queue. You need to communicate between native and Flutter. So that's quite a big task to implement that. Of course, it depends on your app. Maybe you're using public API and that's not even a problem. So it depends on the use case. But typically, this makes the implementation of networking much harder in Add2App. A couple of points on overall developer experience of using Add2App is that this is more of a organizational point, but it was very important in our case. is that development setup might not be straightforward in a corporate setting. Bank being a huge organization, also very security aware, being a financial institution. Before we could even fetch any package from pub, it took us a month to actually do it on bank computers, because there were proxies, VPNs, artifact management systems, all of that which was not really our responsibility, but the DevOps team had to take care of that. It all takes a lot of approvals, and generally worthy to remember that if you, for example, are to estimate how much it would take to write a Flutter app. Working on the UI is great, as I said. Interesting point is that you can actually run this Flutter module outside of the native app. So your Flutter module is a standalone Flutter app itself. So you can just run it and it will render your Flutter screen. Of course, if you have any native dependencies that you depend on, this will probably not be that easy. You could mock it or something. It can be very useful during development, and it might not be that obvious that it's possible to do. Overall, we had to debug native apps a lot. So a lot of native experience is needed for that. Having debugger attached both to Xcode, Android Studio, and VS Code was a daily practice for us, at least at the start. And until we had one Flutter engine, the debugging was very simple. When we had multiple Flutter engines, especially as we had a Flutter engine not for the UI, but I'm going to show you in a moment. One of our engines was actually only for Dart code. That made it much harder, so the debugger wouldn't always attach to the right engine, and it was a bit of a pain. Okay, so now how do we actually build all of that? How do we build native app with Flutter? And again, we have two ways of doing this. One is that we treat Flutter as an artifact. So our Flutter module will just be a binary that's attached to the native app. And in case of Android, we have a command flutter build AAR. It builds a local Maven repository, and we can link that to our native app and just use the binary. Similar thing with iOS. We can use flutter build iOS framework. It will produce a bunch of XC frameworks, one for Flutter runtime itself, one for our application code, and then every Flutter plugin that we use will actually be another XC framework, and we can add all of those as embedded frameworks in Xcode. Of course, the main advantage of this might look a bit hard to use, but the biggest advantage is that native devs don't need Flutter on their machines to run the app. So you're not impacting native teams. You're not impacting the native CI if you can easily provide binary. Our first build was actually just pushing these AAR and XC frameworks directly to repository so the native CI could build this. But a more streamlined setup, something that you probably want to use eventually, is using Flutter module, importing it via Cocoa pods for iOS and Gradle Android from the repository. Yeah, so that's the more simple setup, but of course you need to change the CI. Every native dev has to install Flutter on their machine to keep maintaining the native app. So that's something that might take some time to adopt. So that's why you might want to start with artifacts. Couple of points on native code. So as I told you, you will need some native knowledge to develop app-to-app, especially in a big native application. So you will need some developers that can deal with Objective-C, Java, Kotlin, Swift, everything that you might encounter in the native code base. Because Flutter native communication is unavoidable in this scenario. So unless it's only a pure UI, then it might be a couple of lines of code to just initiate Flutter, but in most scenarios, you have some data in the native app, you need to get it to the Flutter module and vice versa. Generally for the communication we used Pigeon. Now it's, I think it's becoming a standard. There's also FFI now. When we first used it, it was not that popular yet. It works really well because it takes care of dealing with a lot of boilerplate. You can also use in your Flutter module, you can use all packages from pub. Also those that have native dependencies that are Flutter plugins, like for camera, Bluetooth, whatever. There are some caveats with that. So if your Flutter plugin that you're importing in your pub spec in the Flutter module has a dependency of sub-native library at some specific version, and your native app also uses that library, the version will have to match. So either you have to change the version in your native app, or you need to change the version, or you need to fork the plugin and change the version there. Changing the plugin might be the quicker way of doing this, but of course you now have a fork to maintain. Or if it's a simple upgrade to the library, maybe you can submit a pull request. But generally it's a bit of a mess to maintain if you're using Flutter plugins. And now the core of our use case, which made it all a bit more complex, is that we had to do some background processing in our add-to-app module. So a very high-level overview of what we actually did in our project is that we have a native screen. From that native screen, we could open our main Flutter module, which had a couple of Flutter screens. But from one of those screens, you could initiate an action that would have to work in background for a couple of minutes and check some status. It was generally a pretty complex state machine with many states. And in case of Android, it used foreground service. On iOS, we were able to do it with background tasks. In more complex scenario, background fetch would be necessary. And this background service, this background isolate, would, at some conditions, if some conditions are met, then it started another Flutter screen, which was like a dialog style. This dialog had to appear either on top of the Flutter screen or a native screen, depending on where the user was in the application at that time. Of course, there were also some notifications involved. So as you can see, we actually had 3 Flutter engines, one for the main UI part, one for the background. So the background was just a Dart code. It had no UI, but it was a separate Dart isolate. And then we had another module for dialogues. It had to be also a separate engine because it could be started on top of a native screen, because the user could navigate around the app whilst this process was running. So the communication between those parts of Dart running were via isolates. So you can communicate with isolates with this background process running inside of a foreground service and the main and dialog module. And all of that was because we wanted to prove that the core business logic, which laid in that background isolate, could be rewritten in pure Dart and could actually be shared between iOS and Android. And that was our main point to prove. that we didn't have to resolve to just copying the native implementation. So, of course, if you add Flutter to your app, the app size has to increase. In our case, it was 27 megabytes for iOS, 15 megabytes for effective APK downloaded from store using AAB for uploading to stores. Funny anecdote is that we found out that the bank was still using raw APKs to upload to the Play Store, which is now not possible, at least for new apps. So actually using Flutter there was also optimized their native procedures for store upload, because with APK that number was much bigger. So what are the performance implications? So those are some numbers. They are from Flutter docs, which are a bit outdated at the moment. But from our research, they are the order of magnitude that you might expect from it. So the engine pre-warm, as I told you, is quite an expensive operation. So it can be close to a second on iOS. On Android, here it's even 1.5 seconds. It's for some low-end device, but still your users might use low-end devices. Also, rendering of the first frame is much slower than further frames, but that's not such a big problem. The bigger problem is the engine pre-warm. So you need to pre-warm the engine at some convenient. You need to develop some heuristics in your app when to pre-warm the engine. It might be right after a start, right after login, or when you're on a navigation path that might lead to Flutter, so you might start initializing it if you see that the user might end up in a Flutter module. So yeah, this is some operation that you have to plan in your app if you don't want to decrease the user experience. A small note on UI testing, so a small plug of our library, Patrol, which can be used actually to, because Patrol supports native integrations, so you can use it to test your Flutter module inside a native application, because you can go both through the native screens and the Flutter screens. If you want to know more about Patrol, you can ask me or my colleagues from Lean Code. We're happy to talk about it. And one more thing is that there are some challenges that are not technical with all of that. So there are more organizational problems. So the first one is that you're entering a huge native app. It will have some technological debt. So you have to deal with some legacy code. We actually had no documentation on how this module actually worked. Neither technical nor business documentation on that. No modern design tools, so we had to copy the UI, but we had no Figma, no Adobe XD. We were just running the native app and measuring pixels effectively, which is not ideal, and which is also something that you might say it will be easy to copy the design, but if you have no measurements of paddings of everything, it will take more time than you planned. And native code is your ultimate source of truth in that case. So we had to rewrite the module based on some old Objective-C and Java code because we had no other resources. And you will need expertise in both Flutter and native technology. Also, if you're entering with Flutter an organization that has native teams, native developers can be very reluctant to switch to Flutter. They can be very skeptical about the technology. They love the technology that they use. They can see it as a bit of a threat to them. So that needs some soft skills to make all of that work. And to finish up, the main takeaways from all of that is that I don't need to tell you that, but every project is different. So those are experiences from my project, but sometimes Flutter 2 app is a good choice, sometimes might not be such a good choice. A thing that will always make your life easier is trying to isolate the Flutter module as much as possible and let Flutter do what it does best, which is the UI. Add 2 app brings some issues that you will not encounter in pure Flutter apps. Before starting a project, think about other factors like organizational structure, technical debt, whether you have documentation, whether you have designs in a form that is easy to implement. And that's all from me. Thank you.